Hello boys and girls, this is Mr. Cpctc, and in this video we're going to be looking at Cpctc. So what is Cpctc? Well, it stands for Corresponding Parts of Congruent Triangles are congruent. Because, we've talked about in the past, with these different theorems, SSS, SAS, and all those. And just because we only mark down certain things, like certain sides or certain angles, doesn't mean the rest of it is also not congruent after we have said that the triangles are congruent. So we use Cpctc in proofs when we're asked to prove parts are congruent. So, if we're asked to prove that certain sides or certain angles are congruent, we're going to use that. But before we even get to that, we have to prove that the triangles are congruent first. Because that makes sense. Once you have said two triangles are congruent, then by definition, every part of it has to be congruent to each other. So we're still going to utilize the same things in terms of, if there are shared lines and vertical angles, we'll need to mark those down. But the thing we're going to add here is maybe vocabulary. Vocabulary may play a role in determining if things are congruent or not. So if we look at number one, it says line segment AB is congruent to line segment AD, line segment BC is congruent to line segment DC, and we want to prove that angle BCA is congruent to angle DCA. Looking at the picture, we cannot make a statement. We can't just say, oh yeah, BCA is congruent to DCA because they're vertical angles. So because they're part of the triangle, we must first prove that the triangles are congruent. So first things first, let's write down the given. AB is congruent to AD. That's given, and therefore we can just mark that down. BC is congruent to DC. Why? Because it's given, and therefore we can mark that down. Now, let's look at the picture. Is there anything in the picture that we can mark down? And the answer is yes. It's what we've been doing in the past. We can mark down the shared line AC. So to officially write it down, we would say AC is congruent to AC, and then Y. And the answer is not because it's a shared line. The answer is, well, think back to algebra, and we did talk about this in the past. Starts with an R. The answer is because of a reflexive property. The reflexive property says that something is equal to itself. And that's what we have here. AC is equal to itself because it's shared reflexive property. So now, do I have enough information to say that the two triangles are congruent? And the answer is yes. These two triangles are congruent by SSS. So we'll say triangle ABC is congruent to triangle ADC because of the SSS theorem. So now, since I have proven that the two triangles are congruent, now I can talk about all the other corresponding parts if they are congruent. And so now we can go and say angle BCA is congruent to angle DCA because of Cpctc. Those angles in the triangle are corresponding to each other, and because those triangles are congruent, those angles must also be congruent. Thus, Cpctc. All right, let's look at another one, number two. Number two, it says given line segment PS is, remember that means parallel to QR. So PS is parallel to QR. Why? That's given. And I'll also mark that down in the drawing. Remember, arrows indicate parallel lines in the drawing. Next one, angle QPS is congruent to angle SRQ. That's given, and I'll mark that down. So now, is there anything in the picture that I can mark down, like a vertical angle or shared line? And the answer is yes, so there's a shared line, QS. So I'd say QS is congruent to QS because of reflexive property. Now, picture-wise, that's it. There's nothing else I can mark down, picture-wise. So, and what I have, too, is not enough information to say that the two triangles are congruent. So, I gotta go back to my givens and see is there some sort of like vocabulary maybe that was mentioned. And technically there is. It's this first part right here where PS is parallel to QR. Remember, I believe it was chapter 3, when two lines are parallel, that does not mean they are congruent. So you won't say PS is congruent to QR. We don't know that. All we just know, though, however, is that they are parallel to each other. Think back to chapter 3 again. What does that mean when two lines are parallel and I have some sort of line that crosses the both of them? Say, for example, QS. Well, in that case here, if you remember, these two angles right here are congruent. We have PS and QR being parallel to each other, and QS is a transversal that goes to them. And why are those two angles congruent? Why is angle PSQ congruent to angle SQR? Think back. Take a moment. Think back. What kind of angles are those? Those are alternate interior angles. So yes, previous reasonings and definitions and whatnot will come into play with this. So now, do I have enough information to say that these two triangles are congruent? And I do. I have two angles on the side mentioned in both triangles and the sides after the two angles. So I could say triangle PSQ is congruent to triangle RQS because of AAS. I have proven that the two triangles are congruent, so now therefore I could talk about their parts. So I can say PQ is congruent to RS because of Cpctc. Right. So most of it, so that's how you do these problems here. And most of it is stuff we've already talked about here. It's just that now we're throwing in some vocabulary and past theorems and definitions that, yes, we do need to remember in order to solve for these problems. Right? So, yes, there are more examples here, but I'm going to see what you guys can do with those here. So I'm going to stop right there. And please refer to the notes I give you on what problems I would like you to try. Right? And refer back to these two problems and see if you can get the rest. Okay? If you got any questions or concerns, please let me know. This is Mr. Cpctc signing off.